today we're going to go through lesson 4 of our probability unit. There's nothing super new here, but we're going to throw permutations and combinations into the mix. So it's going to be a little bit of our last unit mixed in with our current unit. So sometimes using perms and coms is an easier and more efficient way of solving these problems. So let's look at a couple of examples. So Jamal, Ethan, and Alberto are competing with 7 other boys to be on their school's cross-country team. All the boys have an equal chance of winning the trial race. Determine the probability that Jamal, Ethan, and Alberto will place first, second, and third in any order. So just like our perms and coms unit, you're going to have to think carefully, is this going to be a permutation or a combination question? Because I said in any order, that means order doesn't matter, and this is going to be a combination question. What I like to do first is think of my total ways possible. Remember, probability is always what you want, whatever you're looking for, divided by the total possibilities available. So I like to look at my total ways first. We know it's a combination. We're trying to choose the top 3 people on this team. So if you look, there's 10 total boys, and I want to choose groups of 3 of them for the top 3. So that's going to be the total ways I can choose groups of 3 of them. So if I want to now find the probability, it's what I want over the total. I already figured out the total is 10, choose 3. What I want is to determine the probability that Jamal, Ethan, and Alberto are going to be in that top 3. So that means out of Jamal, Ethan, and Alberto, out of those 3, I have to choose all 3 of them. And that's what I'm looking for in my group, that those 3 are my group. Then you just have to type it into your calculator. If you do the top and then the bottom, you'll see that your probability is 1 out of 120. The next question is pretty similar. It says, suppose Zachary is also trying out for the team. So now there's 11 runners in the trial race. We want to know what is the probability that 3 of those 4 boys will place in the top 3 positions. So same thing, it's a combination question. We're going to think our total ways now there are 11 boys, and we are trying to choose groups of 3 of them. So if I want to figure out my probability, the total possibilities of top 3 winners would be 11, choose 3. And now what we want is to figure out the probability that out of these 4, 3 of them will be in the top 3. So that means out of those 4 students, we want to choose 3 of them to be in the top 3. And if you type that in your calculator, you're going to get 4 out of 165. Okay, let's try a couple more. I'll kind of skip around a little bit here. The next one says, Bo hosts a morning radio show in Saskatoon. To advertise his show, he's holding a contest at the mall. He spells Saskatchewan with letter tiles, so just like they're on Scrabble tiles. Then he turns the tiles face down and mixes them up. He asks Sally to arrange the tiles in a row, and then we're going to flip them over, and if she spells the word Saskatchewan, she gets to win a new car. We want to determine the probability that Sally will win the car. So again, first thing is we're going to think, is it a permutation or a combination? We're arranging the tiles into the word Saskatchewan. Order matters here. If it's in a different order, she no longer wins the car. So this is a permutation question. I again like to think of my total possibilities first before I do anything. I have tiles with the letters for Saskatchewan on them. That's 12 different tiles to arrange. So 12 factorial ways to arrange them. But don't forget, we have to divide off the repeats. So S repeats twice, and your A repeats 3 times. So we're going to put that in our calculator. Make sure you put brackets around the bottom part when you put it into your calculator. You're going to see that your total for your probability is going to equal 39,916,800. That's how many different ways those tiles could be arranged. Then we're going to think, how many options do we have for getting it right? To flip over Saskatchewan exactly, there's only one option to do that. It has to spell Saskatchewan. So there's only one way you could actually win. out of all the total different possibilities that there are out there. So that would be your probability for this one. The next question is very similar, so I'm going to skip that one. Let's go on to the next one where we look at some marble questions. So you have to be kind of careful, again, thinking combination or permutation. So we have a bag of marbles. It contains 5 red, 3 green, and 6 blue marbles. So all in all, I have 14 total marbles in the bag. If a child grabs 3 marbles from the bag, we want to determine the probability that exactly 2 are blue. So if you think about it, when you grab it, you have 3 marbles in your hand. Does it matter if the first 2 are blue or the last 2 are blue in your hand? Or it'll still be the same result no matter which order you grabbed them. You'll still have the same result. So this is a combination question. Again, I'm going to think to myself, first let's do our total possible ways of grabbing the marble. So there's 14 total marbles. I'm choosing groups of 3 of them. So that's going to be my total. If I want exactly 2 blue, remember with combinations it's nice to write it out in words first. So that means I need 2 blue marbles in my hand, and I'm going to need 1 of something else in order to get my 3 marbles. 2 blue and 1 something else. So for the top, to get 2 blue, there's 6 blue marbles in the bag. So out of those 6, I have to choose 2 of them. And out of the remaining other 8 marbles, the red and green ones, I'm going to have to choose 1 of those ones. And that's how we'll get our probability here. You're going to type it in your calculator. And when you simplify it, you should get 30 out of 91 for your probability. Okay, let's check the next one here. It says at least 1 is blue. So similar situation. Our total ways we can choose our marbles is 14, choose 3. But now at least 1 is blue. There's a few different scenarios. I could have 1 blue and 2 other marbles. Or I could have 2 blue and 1 other marble. Or I could have all 3 blue marbles. Those are all the scenarios that would work in this case. So then we're going to write it out. For my probability, on the top, 1 blue, there's 6 blue marbles, I need to choose 1 of them. And there's 8 other marbles, I'm going to need to choose 2 of them. Or I need 2 blue marbles out of the 6 and 1 other marble. Or I need all 3 blue marbles out of those 6. And then just be careful typing that into your calculator. When you simplify that, you should get a final answer of 11 over 13. Okay, let's look at the next question. It says when we grab our marbles, the first is red, the second is green, and the third is blue. Be careful now because now order matters. The first has to be red, the second has to be green, and the third has to be blue. So this is now a permutations question. So let's think of our total first. We're picking 3 marbles. There's 14 marbles in the bag, so I have 14 options for my first marble. Once I have it in my hand, I only have 13 other options for my next marble, and then 12. That's going to be the bottom for my probability. Now look at what we're actually wanting. What we want is that the first is red, the second is green, and the third is yellow. So then I'm going to think, how many options do I have for red? I have 5 options for red. How many options of green marbles? I have 3. And how many options do I have for, oh, sorry, this is supposed to say blue. How many options for blue marbles? I have 6. So that's going to be your top number. And when you type that in and simplify it, you are going to get that as your answer. But notice the difference with the next question. It doesn't say it has to be first, second, and third. It says just 1 has to be red, 1 has to be green, and 1 has to be blue. Order no longer matters in this one, so now it's a combination again. We figured out our total for our combination before. It's 14, choose 3. Now I need a red and a green and a blue. So out of the 5 reds, I need 1 of them. And out of the 3 greens, I need 1 of them. And out of the 6 blues, I need 1 of them. That's going to make up my total, which when you simplify it, should give you this answer here. Okay, we'll do one more. So the next one here. We have a lock on a briefcase. It has 3 wheels, each labeled from 0 to 9. What is the probability of a person guessing the correct code if there are no repeated digits in the code? So again, let's look at our total possible codes we could have. There's 3 wheels, and it could be any number from 0 to 9. So that means there's 10 options for my first number. It says there's no repeated digits, so I only have 9 options left, and then 8 for my last number. So when you add those or multiply those all together, you're going to have 720 different possible codes for this lock. So what are your chances of guessing the correct code? Only 1 code is going to be correct out of all the 720 options. So that will be your answer there. The rest are filled in on Google Classroom Notes, so you're welcome to have a look at that, and have a great day.